All right, everybody, good morning. Can everybody see my screen on here with the section we left off with and then the screen, the whiteboard? Good. All right, before we get started, we're gonna pick up in section, what are we in, section 5.5. Does anybody have any questions for me? Was everybody here when we talked about the final exam? Was anybody listening when I talked about the final exam? Just a reminder, we will be using Honor Lock for the final. It's going to start next, like a week from Thursday. So May 7th is going to be when the final opens up for everybody. So I'm going to be posting the directions and the worksheet again this week in an announcement, just so that everybody can get familiar. I want to make sure everybody reads through the directions for Honor Lock. I know it's got some glitches, but I think some of the glitches can be avoided if you read through the step-by-step. The second thing I want to talk about really quick is Camscanner. If you have a scanner at home, like a printer scanner, you don't need to use the app. You can scan them and email your worksheets to me. The Camscanner app for your phone is for people who don't have a scanner to use. And I've actually started using it for a lot of my kids' schoolwork to turn into their teachers. And the Camscanner app really isn't too bad. It's who charges, Joy? Camscanner or Honor Lock? Neither one of them charge. I've got the free version of both. Camscanner, it does. There's a free version, Joy, and I've been using the free version because I'm not paying for it. So it might ask you to upgrade, but you don't need to. And I've been using it now for a few weeks since our last exam for the kids' school stuff. So maybe make sure you read through the directions to make sure they don't charge. Like whatever, maybe you downloaded a different version or a paid version, but there is a free version that you can use. And like I said, it's only if you don't have access to a scanner. And what's great about Camscanner is if you just take a picture of your work, it can sometimes be very hard to read because it doesn't, the background might not be white, but it's not great. It was hard for me to read a lot of people's work, and I might have missed extra points that I could have given. When I use the Camscanner app, what's really cool is it takes a picture, but then it makes the background whiter so that the reading is much easier to see, like as if it's being scanned in a scanner. So just make sure to read through the directions. Make sure, like I said, Joy, that you've got the free version. Like I said, I've been using it and I didn't pay anything. And I promise you, I'm very careful with making sure what I'm paying for or not. So I'm not something I missed. So again, I'll post those directions this week just to make sure everybody's familiar. If you have questions, did you find it in there? Yes, it's in the App Store. So you just have to look up Camscanner. It's pretty easy to find, easy to download. So I would just give it a shot and see if you can figure it out. You can even play with it this week. You don't even have to send me work. Play with it and email yourself some papers that you scan just to test it out, is what I recommend. All right. So we left off last week, and I don't know if you guys remember, we were comparing decimals and fractions. So we left off and we had done a little bit of that or talked about it, but we needed to start with, on your turn 3, part A. Did we get through this one? Do you guys remember the 7/8 and 0.88? Or that's the one we already checked, right? We finished this part. So let's go down here. We left off with part D here. Let me see. Okay, so we did finish 5.5. Just trying to see what I wrote down here. All right, 5.6. I guess I wrote, shoot. Part 3, part A. Okay, so we need to start with 5.6. Do you guys remember this? Did we cover this on Thursday? I don't think so either. Okay, so we did finish up 5.5 though. I do remember that. So let's go ahead and get started. Okay, so today we're going to talk about how to evaluate algebraic expression with decimals. We've done this several times. We've done this with positive integers. We've done this with the whole numbers, with negatives and positives. We've done this with fractions, and now we're doing it with decimals. Nothing's changed here. The only thing now is that we're looking at decimals. So we'll use the same process here as we did when evaluating algebraic expressions in earlier chapters. The only difference here is that the replacement values for the variables and some of the numbers in the expression itself will be decimals. So here's an example. Evaluate x plus 2.5 when x is equal to 1.1. All you do is plug that 1 point in for x and add the numbers. So the process is to replace the variable with the given value and then simplify the result using the correct order of operations. So on your turn 1, we have evaluate the following algebraic expressions when x is equal to negative 3.4 and y is equal to 0.7 and z is equal to 0.6. Let me write a little bit of these down just really quick. Negative 3.4, 0.7. And don't worry, I'm not doing any of the work. I'm just copying the numbers down, 10.6. All right, and then part A, we have y minus negative 8.32. All right, so all we need to do is plug the number in. So we don't care about x or y, or x or z, right? Because all we have is a y. So what we're gonna just take is that y and plug it in there. So now we have 0.7 minus a negative 8.32. Now, when we subtract a negative, what does that turn into? A positive. Very good. That turns into addition. So now we're going to say 0.7 plus 8.32. Now, this one I can tell you right now is going to be 9. When you add those together, you get 9.02. But I will say this. You guys do know how to add these. You guys know how to add these numbers manually. And so I'm going to have to do a lot of this in the calculator if the numbers get a little more difficult than this, only for time's sake. And you guys know how to do this. So when you add 0.7 and 9.32, that gives us 9.02. All right, so let's go ahead and look at part B. So now part B, we're going to have the same values, those x, y, and z values, right? But now we're going to do part B. Part B tells us we have 2x plus y squared. So now we have an x and a y, so we have to put them both in. So we're going to say 2 times negative 3.4 plus 0, oops, just put a 0 there, 0.7 squared. So now I need to start thinking about my order of operations because I have more than one thing going on here. So what are my order of operations again? We have grouping symbols, exponents, multiply, divide, add, and subtract. So what's the first thing I need to do here? Does anybody know what order of operation I need to do first, or what operation I need to do first? Do I have any grouping symbols? You're saying do this first? What about our exponent here? Remember, these parentheses in this part are not grouping symbols. Those are a shorthand for multiplication. Remember, when there's no operation inside of the parentheses, it's not a grouping symbol. So what do we need to do first then? We have an exponent, right? So we need to do that exponent first. Let me move this over. All right, so we need to do that exponent first because that's our first order of operation that shows up. All right, so we have 2 times negative 3.4, and then what's 0.7 squared? What's my base? The base is 0.7. So how do I do that? We just do 0.7. That's the same thing as saying 0.7 times 0.7, right? Any guesses what it is without doing it in the calculator? Just based on our little tricks, our shorthand from before. .49, very good, 0.49. That's right, because 7 times 7 is 49, and we have 1, 2 decimal places, so we end up with 0.49, very good. So plus 0.49. Now again, if you don't know that shortcut, you can just do it in your calculator. All right, so now that we've done our exponent, we're done with our second order of operation. Now we need to move on to the third and multiply and divide. And Shannon, that's what you mentioned earlier. We need to multiply 2 times negative 3.4. So 2 times negative 3.4 gives us negative 6.8 plus 0.49. When I add those together, we get, negative 6.31. Any questions about that? Is this all pretty straightforward to you guys? Yes, okay, good. All right, let's go ahead and do, since we've already got the numbers written down, we'll go ahead and do C. All right, so C gives us 84.8, oops, it's a bad 8, divided by Z plus 2X. So the first thing we need to do is put our numbers into the problem. What page is this, Sylvia? We are on page 56. All right. Okay, so we're going to plug the numbers in. So all we have are, why did I write that? Those are from before. Okay, so we have an X and a Z in this one. So we don't really care about Y though, right? We just care about the X and the Z. So we're going to plug those numbers in. So we have 84.8 divided by Z is 10.6 plus 2 times X, which is negative 3.4. So, oh, is Kim? Oh, Kim, okay. All right. All right, guys, so now we have to do our order of operations again. Remember, we have grouping symbols, exponents, multiply, and divide. We don't have any grouping symbols, we don't have any exponents, but we do have multiply and divide. So remember, we kind of need to go left to right. It's just a way to keep track of everything. So the first thing we need to do is this, and then we can do this. Now, when we say left to right, the reason we talk about that is if you have more than 2 numbers in a row. Here we only have 2 numbers at a time, so we can do them in the same step because they don't affect one another. So we can go ahead and say 84.8 divided by 10.6, 84.8 divided by 10.6, and that gives us, oh, is that 8 even? Wow, it gives us 8. So I'll write it like this so it's a little clearer. That gives us 8. All right, and then we need to multiply over here. Okay, so we have 2 times negative 3.4, and that gives us negative 6.8. All right, so now we're adding a negative. So what is that the same thing as? Subtracting, very good. So that's the same thing as saying 8 minus 6.8. Let's go ahead and type that in, 8 minus 6.8, and that gives us 1.2. Everyone good with that? All right, good. Let's go down. Let's do one more of these. I want to do part C on this one. So we've got so we're on page 57, part C. We have 5yz plus 11.1, where y equals 1.5 and z equals negative 2.5. All right. So we need to plug those numbers in. So we have 5 times 1.5 times negative 2.5 plus 11.1. So here's where that left to right comes into play. So our first order of operation here is multiplication, right? We don't have any grouping symbols, we don't have any exponents, so we need to multiply first. So in this case, you could do a couple ways. You could first multiply these numbers and then multiply that answer by this, or you can just do them all together. So we could say that 5 times 1.5 times negative 2.5 is negative 18.75 plus 11.1. All right, everybody okay with that? Okay. So once we then subtract that, we're down to last thing. So we have negative 18.75 plus 11.1. Just looking at that, do you guys think the answer is going to be positive or negative? Negative. Very good, Joy. The reason it's going to be negative is because that 18.75, that negative number, is bigger than the 11.1. So we're starting all the way over at like almost negative 19 and only coming back about 11. So we definitely expect it to be negative. So when we type that in, we do negative 18.75 plus 11.1, and that gives us negative 7.65, which is what we were expecting. All right. Any questions on those? All you do is you take those numbers, you plug them in for the variables, and then you do the order of operations. Exactly what we've been doing this whole time, since the very beginning. All right, so now part B, decide whether a decimal number is a solution to the equation. Can anybody tell me, if we are given a number and we want to know if it's a solution to the equation, what do we do? Does anybody know what we do? Plug it in. Very good, Joy. After we plug it in, then what do we do? We need to see if both sides are equal, right? So we simplify both sides down, and if both sides are equal, that tells us that that number is a solution. If the sides are not equal, that tells us that it's not a solution. So to decide whether a decimal number is a solution to an equation, we'll use the same process as in earlier chapters, like I just explained. So we replace the variable, simplify both sides. If the statement's true, that means that both sides are equal, then it is a solution. If the final statement is false, that means it's not equal, the value is not a solution. Soon we'll learn how to solve equations in containing decimals, but for now we're just focusing on testing, which is exactly what we've done in previous chapters. As you can see, the highlighting is getting a little crazy. It was getting very hard to make it look better. So here we're on page 58, and it's asking us, is 5.4 a solution to 3, open parentheses, x minus 2.9 equals 2.1 plus x? Let me write this down. So we have, actually, let me just do it. Well, let's do this. So we have 3 times x minus 2.9 equals 2.1 plus x. All right. So what's the first thing we need to do? We need to plug it in like we just said. So we have 3 times 5.4 minus 2.9 equals question mark 2.1 plus 5.4. So order of operations, number 1 is grouping symbols. So we need to do what's inside of here. So we're going to get 3 times, and if we do 5.4 minus 2.9, we get 2.5 equals question mark. Can I go ahead and add these on this side in this step? Yeah, we can, because we're simplifying on both sides. So what I do on this side does not affect what I do on that side. So I'm going to say 2.1 plus 5.4 equals 7.5. Now we need to do the last operation, which is 3 times 2.5 gives us 7.5 equals 7.5, which is true, which means that 5.4 is a solution. Okay? Because both sides were equal. All right, let's look at another one. Let's go down here. So let's do one with a whole number, with decimals otherwise. So let's look at part A. We have 7, a solution to 0.6x plus, I should start writing a 0 in front. I normally don't. 0.9 equals 0.8x minus 0.5. All right, first step, plug it in. So we have 0.6 times 7 minus 0.9 equals question mark 0.8 times 7 minus 0.5. So the first thing we need to do is that multiplication. So we have 0.6 times 7 on the first side, on the left side, excuse me. So we have 4.2 minus 0.9 equals question mark. And does anybody know what this 0.8 times 7 is without doing it in the calculator? Remember, if you just multiply the numbers as if they're whole, that's 8 times 7 is 56. Very good. Well, close, mate, Shane, very close. We only have 1 decimal point here. So we actually need to have 5.6. And think about it this way. 0.8 is like close to 1. So we expect the answer to be like a little closer to 7. So because it's 8 times 7, we only have 1 decimal point, it's 5.6. If you don't remember that, you can do it in your calculator also. That's just a shortcut. All right, now we need to do the subtraction. So we have 4.2 minus 0.9, which gives us 3.3 over here. And on this side, we have 5.6. Does anybody see where this is going? We have 5.1, which means these are not equal. So that means that 7 is not a solution. Oops, solution right there. Okay, so 7 is not a solution. All right, let's look at one more of those, part B. Does anybody have any questions about this? Or does it seem very familiar from the other steps we've taken in previous chapters? No questions yet. That's good. Okay. All right. So let's do part B. We have negative 3.3. And our equation is 28.56 equals 6.2x plus 8.1. What's the first step? Plug it in. All right, so we're gonna take that negative 0.3 and plug it in for x. So we have 28.56 equals question mark 6.2 times negative 3.3 plus 8.1. All right, so we don't need to do anything on this, the left side, right? That one's already reduced and simplified down, but we do need to multiply on this left side. So we have 6.2 times negative 3.3, and that gives us negative 20.46 plus 8.1. Any thoughts about whether or not this is going to be a solution? Okay, well, let's go ahead and subtract and find out. So 28.56, and on this side we have negative 20.46 plus 8.1. And that gives us negative 12.36, which means that's not a solution. Okay. Let's go ahead and do this part C. We have 7.1, and the equation is 0.5 times x plus 3 equals x minus 2.05. All right. So the first thing we need to do is plug it in. 7.1 plus 3 equals 7.1 minus 2.05. So we need to first do what's inside this parenthesis. Oh, we need to write a question mark. 0.5 times 10.1, because 7.1 plus 3 is 10.1, equals question mark. We have 7.1 minus 2.05, and that gives us 5.05. So now we're going to multiply 0.5 times 10.1, and that gives us 5.05, which equals 5.05. So that means that 7.1 is a solution. Oops. All right, everybody go with those? Yes, good. All right. All right, now we're going to talk about how to simplify expressions containing decimals. So remember what we've done in previous chapters too, is that we built on it. So first we learned how to substitute numbers, then we learned if it was a solution, then we learned how to simplify. So we're building the steps again, just like we did before, but now we're adding in decimals. So as we saw in earlier chapters, when simplifying expressions, we must clear parentheses by distributing and or combining like terms. The only thing new here will be the decimals. So combining like terms is when you identify the like terms and combine their numeric coefficients. Distributing is when you multiply through. So in this case, like this example in the last section, we just had, we were replacing. So we had a number, but here we don't have a number, so we have to distribute. Here's an example where you're distributing and then combining like terms. So distribute to remove parentheses, combine like terms. Important notes, remember when combining like terms, we're combining their numerical coefficients using the distributive property. So this is kind of doing it in a way that shows you how it works. So for example, 0.3x plus 0.2 is the same thing as saying 0.3 plus 0.2 all times x. So because if you were to distribute that x through, you would get this. So this is showing you why you can say 0.3x plus 0.2x is 0.5x. A simplified expression has no like terms and no parentheses. A simplified expression is equivalent to the original expression, it just looks different. The ability to simplify expressions is essential for future success in algebra. All right, so let's go down. We're on page 59. Let's go down to your turn 3 and part A. Again, we have done this several times. This is very similar. We just now have decimals. Now we have 15x minus 5.32x minus 1.27x. So which of these are like terms? Anybody know which of these are like terms? They are. What about that 15x? These are actually all like terms. Very good. That's okay. It's also my handwriting sucks, so that's probably part of it. So since these are all like terms, we just need to combine their numeric coefficients. So we can say, I'm just writing this out to show you guys, 5.32 minus 1.27 all times x. So 15 minus 5.32 minus 1.27 equals 8.41x. Now again, you don't need to write this step. I'm just writing it just to show you guys for the first one, especially because there were 3 terms. All right, let's go to the next one down here, because we're going to go through a few of these. So let's look at part A. We're on page 60. So now we're looking at distributing also. So 6 times 2x plus 1.1. Okay, so we need to multiply through, right? So 6 times 2x gives us 12x plus 6 times 1.1 gives us 6.6 6.6. Now, is that simplified? Is there anything else I can do? The answer is that is simplified. There's no other like terms. You have an X term here and a numeric term here. There's nothing else to combine. There's no parentheses, so this is simplified. Let's do part B. So we have -3 times 4x minus 0.3 plus 1.1, oops, 1.1. So our first step here is to distribute again. So we have -3 times 4x gives us -12x. Then we have, I'm trying to make this look pretty, a -3 times a -0.3. Remember, that's going to give us a positive 0.9. So plus 0.9 plus 1.1. Is that simplified? No, it's not, right? We have, these are like terms. There's nothing to combine this with, so that part's done. 12x. So we have 0.9 plus 1.1, which gives us 2. So that's our simplified answer. There's nothing to, there's no more terms to combine. All right, let's go to part B, and on your own. Anybody have any questions? You guys, does this just look super familiar? No questions? Yeah, if, oh, or you said no, that one's not simplified. Anybody have any questions? Okay. And the kind of nice thing about this is if you had a harder time with this earlier, you're getting another chance to learn it now. So take this chance or take this opportunity to really try to understand it. So what do I need to do? Do I need to distribute? Or do I need to combine like terms? Combine like terms, very good. These are our like terms. There's nothing to combine that with. So we just need to combine the numeric terms. So we have 7.24 plus 5.21 gives us, oops, here you go. 12.45 A plus 3.39. Is that simplified? Yes. Okay. Give me just 1 second. I'm sorry. Sorry about that. Okay. All right. Okay. So let's go ahead and go on to solving decimal equations. So, because like I said, we've gone through several times with how to simplify. So that part should be clear, but if you have questions, let me know. But what now we're going to do is combine all of those into solving algebraic equations. So we will use the same process as we did when solving equations in earlier chapters. With decimals, the solving is a bit trickier, but the process is exactly the same. And I think you guys are going to find that it's still intimidating with the decimals, but it's probably a little bit easier than with the fractions because you can more easily check it in with your calculator, right? So let's go ahead and go down. So the process, simplify both sides of the equation. If fractions are present, multiply both sides by the equation by the LCD. Don't freak out. They only wrote that there because it's a complete list for your algebraic equation, solving equations. We're not going to do fractions at all in this section. You just need to focus on decimals, but it's important to remember that for when it comes back. All right, then distribute to clear parentheses, combine like terms, use the addition property to get the variable term alone on one side of the equation, use the multiplication property to isolate the variable, and then check the solution in the original equation. It says the same thing here about the fractions, so don't worry about that. Let's see. Oh, and it says see the FAQ at example 6A for a way. We're not going to, it talks about how to solve a decimal equation by clearing the decimals first. We are not going to go through that. But if you go through the videos, you can find a video about that. But we're not going to cover that. Or we're not going to worry about that. We're just going to solve it with the decimals. And then be sure to check your answers in the original equation. So let's go down. We're on page 62 now, part A. So we have 16.58 equals y plus 7.6. All right, so remember, we have to simplify, then we have to use the multiplication property, and then we have to use the addition property. We don't have anything to simplify. There's no like terms on both sides. There's no parentheses to distribute. So we don't need to worry about that. There's no, or excuse me, we need to use the addition property because what we need to do is get that variable term by itself. So we're going to subtract. Remember, to get that, we need to subtract 7.6 from both sides. Remember, the idea when you get that by itself is to cancel out the other term. So in order to cancel it out, you have to subtract or add based on whatever number you have, and then you have to do it to both sides. One of the things I saw in the exam was people not doing it to both sides. Remember, think of it like a teeter-totter. You have to keep the balance. So these can't, 7.6, 7.6. These cancel, and then we need to do 16.58 minus 7.6 on the left side. That's going to give us 8.98 equals y. Now, there's no numeric coefficient here. If there's no coefficient there, you don't need to do the multiplication property step, right? That's already our answer. And let's just this once or twice, I'll show you how to check it. So let's plug it back into our original equation to see if it works, right? 8.98 plus 7.6. So this one's pretty basic, plus 7.6 gives us 16.58, 16.58. And since they're equal, that means that this solution is correct. All right, let's go to the next one. So part B, we have 15.3 equals 5.1x. So what's my first step to solve for x? I need to get that. There's nothing to simplify, and there's nothing to add or subtract, right? There's nothing to add or subtract. What do I need to do to get this x by itself? Divide. Very good. We need to divide by 5, not by 5.1x, Shannon, but just 5.1, because we want this all by itself. So we're going to divide both sides by 5.1. Remember, if we divided by 5.1x, we would just end up with 1 on this side. All right, so 5.1 divided by 5.1 just becomes 1. So 1x is equal to x. So this whole side just equals x. And then we have 15.3 divided by 5.1, which equals 3. So there's our answer. And you would plug it back into that equation to check your answer. All right, let's do the next one. The next one involves a few more steps, which is good. So part C, we have negative 9x plus 7.2 equals 2x minus 4.9. So now, in this one, we have a few more steps. We don't have anything to simplify on the left and right side, so we don't have to simplify, but we do need to isolate the variable terms, which means we need to get the variable terms on one side and the numbers on the other side. So that means I start with the variable terms. I would like to have a positive variable coefficient, so I'm going to add 9x, because what I need to do is cancel it from one side. I need to get rid of my x terms on one side and take them over to the other side. So these are going to cancel to 0. We're going to get 7.2 equals 2x plus 9x gives us 11x minus 4.9. Now I need to get this by itself. If I need to get that by itself, I need to get rid of this on this side. In order to get rid of this on this side, what do I need to do? How can I get that 11x all by itself? Does anybody know? Very good, Sarah. We can add 4.9. We do that opposite, right? Add 4.9 to both sides. So that cancels. So now we're left with 11x on that side. And then we need to add 7.2 and 4.9. And that gives us 12.1. Now that I've got my variable terms on one side and my numbers on the other side, I need to get this variable all by itself. In order to do that, I divide by the coefficient there, right? Because I want that to go to 1. And I divide by 11 over here. That cancels. So then we have 12.1 divided by 11. And that gives us 1.1 equals x. And again, I would plug that back into that equation and make sure that both sides are equal. Any questions about that? Does this look familiar to you guys? Good. All right, let's go down. We're going to add in a little bit extra step. I think we're going to go, let's go with part B here. So we have 5 times x minus 2.3 equals 3x minus 6.9. Now we have to do our simplify step, right? Because we have parentheses on one side. So we need to start with that. We have 5x, and that looks like an 8 or a 6, sorry. 5x, and then we have 5 times a negative 2.3. So when we're multiplying like that, we end up with a negative, right? So we have negative 11.5 or minus 11.5 equals 3x minus 6.9. Now, are both sides of those as simplified as they can get? No. What can we simplify on both sides? Remember, we're not solving yet. I just want to ask if they're simplified. Is there any more simplifying on each side? Remember, I wish I could just cover this up. Remember when we say simplify, we're only looking at one side. Is there anything I can simplify on that right side? No, like, very good. There is not. There's nothing I can simplify on these sides. So the only thing I need to do now is solve. So the next step we go to is our addition property to get all the variable terms on one side. So I, again, go with the x's first. I want to get this, I want to get rid of this 3x so that all my x's are on the left side. So 5x minus 3x gives me 2x, and then I just carry down the other part, minus 11.5. 3x minus 3x is 0, equals negative 6.9. Now that I got my variables on one side, I need to get this number over here, right? Which means I need to get rid of it on the left side. So to get rid of that, I add 11.5 to both sides equals, oops, that's not what I wanted to do, sorry. Plus 11.5. So these cancel, so we only have 2x on the left side. And then we're gonna say negative 6.9 plus 11.5 gives us 4.6. Excuse me, yeah, that's positive, yes, thank you. All right. So now what do? I need to get that x all by itself. In order to get that x all by itself, I'm going to divide by 2 on both sides. Those 2's cancel. So now I have x equals 2.3. Because 4.6 divided by 2 is 2.3. Does everyone feel okay with that, or anybody have any questions? Good. Good. Okay. All right, let's do one more of those down here, part C. we have negative 4x, oops, negative 4 times x plus 1.7 equals 2x minus 4.7. This is similar, but I just want to make sure we can all go through the steps of distribute and going through it. So here we're going to distribute on this side. We're going to get negative 4x minus 4 times 1.7. So remember that's a negative, is going to give us minus 6.8 equals 2x minus 4.7. And just like the last problem, there's, oh, thank you, Sarah. Sorry. I just distributed. That's all I did. Thank you, Sarah. Sorry about that, guys. So when you distribute through, there's nothing to simplify, just like in the last one. Again, I want to get rid of the variables on one side and I want it to be on the other side. In order to do that, I'm going to add 4x to both sides. That way it cancels over here. And remember, whatever I do to one side, I have to do to the other side. So I'm left with negative 6.8 equals 6x minus 4.7. So now I need to get that by itself. In order to get that by itself, I need to cancel this out. To cancel that out, I need to add 4.7 to both sides. Those cancel, so now we have negative 6.8 plus, oops, 4.7 gives us negative 2.1 on the left side, and we're left with 6x on the right side. So now I need to get that x all by itself. To get the x by itself, I need to divide both sides by 6. So negative 2.1 divided by 6 gives me, I'm going to write it over here, negative 0.35, and those 6's cancel, so we get x. And I would plug that back into the original equation to make sure that it's correct. All right, everybody feel good about those? Okay, good. All right. So that's it for 5.6. So let's pull up the practice problems. So for 5.6, your practice problems are right here. We have 15, 19, 25, 29, 35, 41, 45, 51, 55, 57, and 61. So the good news is we only have one more section, and we're going to get through as much as we can today. That way we can start the final exam review on Thursday. All right. All right. So let's go down. We're on section 5.7. All right. Now we're going to talk about applications of decimals with money, geometry, and more. Everyone's favorite word problem. So I know it's not your favorite, but the good news is it's the last one you have to learn. And after this, it's going to be all review for the final. So the main idea, use the rules for adding and subtracting decimals to solve application problems. Yeah, I'm sure. So the first one we're going to talk about is, I'm going to go back up and just show you real quick. So first we're going to talk about adding and subtracting. Then we're going to talk about problems with multiplying, and then we're going to talk about problems with dividing, and then we're going to talk about like shapes, like surface area volume of different shapes, both two-dimensional and three-dimensional. So important notes, estimate the answer first, then do an exact calculation. Oh, and always ask yourself whether the answer makes sense for the real situation described. Again, estimating your answers kind of helps you know if your answer is in the realm of reality. So we're gonna go down, we're on your turn. This is on page 68. So Aji had $813.41 in his checking account before he paid the electric bill of $112.34. How much money was left in Aji's checking account after his payment? So we need to know the final balance, which is equal to the start minus that check, right? That bill he paid, right? Everybody's okay with that. So let's look at our numbers. We have his final, we know his start and we know his check, right? So the start is $813.41 minus the check, which is $112.34. So all we're doing is subtracting, right? So we have 813.41 minus 112.34. And that gives, oops, gosh, equals 701.07. I think all of us know how to kind of check our own money. So that after he wrote that bill, he had $701.07. So that's how you would use these. That's a very common application for decimals with adding and subtracting, or just subtracting. Let's look at this fundraising example. So at a recent fundraising event, the following amount of money was collected from the different activities. What was the total amount of money collected? When you guys hear total, what do you guys think we're looking at? What operation? Adding or subtracting? Very good, Joy. Adding. And Shanna, sorry, I didn't see yours at first. Adding. So we're going to add these together. So the total is going to equal 213.75 plus 90.65 plus 182.05. So we just add those all up. Again, we've covered several times how to do these on your without a calculator, but for time's sake, we are definitely doing a calculator today. So that total is going to be 486.45. So that would be the total amount collected from the different activities. Who likes these ones? Oops, I'm sorry, guys. My husband keeps messaging me. Okay. You like those, I'm sure. All right, recently an ill patient had a temperature of 102.3 degrees. If the normal temperature of a healthy person is 98.6, how many degrees above normal is this patient's temperature? Here we go. Any idea? 37. Well, yeah, okay, so 37, 3.7. How did you get there? Did you add, subtract? What did we do? Subtract, right? So what we're going to do is, what we want to know is how much higher, right? So that means we're going to say the patient degrees minus the normal, right? Well, we'll just say healthy. Oops, healthy. So what we would say is 102.3 minus 98.6, which equals 3.7. Very good. Oops, gosh darn it, doesn't show that right there. 3.7. So 102.3 minus 98.6, which is 3.7. All right, so now we're going to talk about how to multiply decimals. All right, so use the rules for multiplying decimals to solve application problems. Important notes: estimate your answer first and check and make sure it makes sense. All right, so we're on page 70, weekly pay. Last week, Justine worked 29.5 hours and was paid $9.55 per hour. How much money did Justine earn last week? If necessary, round your answer to the nearest hundredth. Any idea? So right now we're talking about multiplying, right? Isn't that what we were told, that we're in multiplying mode? And if you think about it, we're given the total number of hours and the dollars per hour. So we need to multiply them to find out how much she got paid total. So the total is going to equal hours times dollar per hour, right? So that's going to equal 29.5 times 9.55. So when we multiply that, we get 281.725. So is that the answer that I would put into MyLab? 281.725? No, it says round to the nearest hundredth. So if we round to the nearest hundredth, we need to round it here. We need to check and see what that one says. That tells us to round it up. So we would write 281.73. That's rounded to the nearest hundredth. All right. Let's look down here at the cost of corn. So here we have the approximate cost of a bushel of corn is $3.69. How much would it cost for 890 bushels of corn? If necessary, round your answer to the nearest hundredth. So we have each one costs $3.69 and we have 890. So we need to multiply to see how much the total cost is. That'd be 890 times 3.69. Again, we can multiply it out, but let's go, we know how to multiply it out, but let's go ahead and use the calculator for time's sake. That equals 3284.1. Is that the answer? Can we go ahead and put that in? It says if necessary, round to the nearest hundredth, but it already doesn't need to be rounded. So you can just input this answer. So the total answer, if we were to say it in dollars, would be $3,000, $284.10. Now, I just want to point out, it's really important for you guys to understand why we're multiplying, because when you go to the quizzes, it won't say this is a multiplication property like it does here. Here we're in the multiplication section, so you know we're multiplying, but you guys need to make sure you understand when it gives you the price per bushel and then how many bushels, and you're looking for the total, that's a multiplication. Now, if you were given the total cost and maybe given the price per bushel, then you want to know how many bushels there were, that would be a divide problem. That's going the other way. So make sure you're paying close attention to the wording so you know if you're multiplying or dividing. So now we're going to use the rule for dividing decimals to solve application problems. Again, estimate and then check and make sure it makes sense. So here we have a stock market. So one share of Orange Inc. stock is $132.50. How many shares can be bought for $10,000? So I'm being told that I have exactly $10,000 and this stock is $132.50. I want to know how many shares I can buy with that money. That tells us that we're dividing. We want to know how many groups of 132.5 are in 10,000. That tells us we're dividing. So we need to divide 10,000. Well, I'm not gonna, sorry, I shouldn't write that dollar sign. 10,000 divided by 132.5. Does everybody understand how that's a divide problem? Okay, good. All right, so when we divide that, we have 10,000 divided by 132.5, and that gives us 75.4717. Can I put that answer into MyLab like that? Nope, exactly, because it says to round to the nearest whole number. So the whole number is here. We look to that 4, it tells us that we keep it rounded down. So we would input 75 into MyLab. Oops, if I can actually show you right there, 75. All right, any questions about that one? All right, let's go down to on your own. So we have miles per gallon. Kai drove approximately 382.9 miles since her last fill up. When she refilled her car, she put 15.5 gallons of gasoline. How many miles per gallon does her car get? If necessary, round to the nearest tenth. So what am I dividing by what? I'm given a total number of miles, and we know that it was 15.5 gallons that got us that number of miles. So what am I dividing? Anybody know? Well, if we're given the total number of gallons, 382.9, and we want to know miles per gallon, we're going to do miles divided by the number of gallons. Miles per gallon. Miles per gallon. Okay? Does everybody understand that? Okay, good. All right, so when we divide that, we end up with 24.7032, and it says round to the nearest 10th. Since that's a 0 next to it, we round down. So we would say that she got about 24.7 miles per gallon. Here's a little trick I learned, and this is confusing to you, ignore me, but when I remember like in physics, this really made it make sense to me. Remember, division is a fraction bar. So if I'm saying miles per gallon, this is what I'm saying, right? We know this from seeing it written, right? That means I need to divide the number of miles by the number of gallons. So that's like a little trick if you need to know which number to divide by which number. Okay. Same thing as like dollars per, if you want to like check, like let's say you want to know, okay, you guys are going to think I'm nuts. Some stores will give you the price per ounce. I think Walmart does it, but I know that Rouse's, I do not think does that. So like, let's say you have like 2 boxes of cereal you're comparing and you want to know which one's cheaper. I always check the price. You guys are going to think I'm nuts. I check the price per ounce. So if I look at the price per ounce, that means I look at the total dollars and then the number of ounces. And you can compare it to see if you're getting a better deal for different cereals if they're different sizes. I know, super cheap and super nerdy. All right, let's go ahead and move on. Price per unit, exactly, price per unit. Not all stores print that. They do in other places. All right, here is our last part for section 5.7. We're gonna look at solving problems that involve pre-algebra with circles, cylinders, surface area, and more. We will now solve application problems that involve formulas and equations. Again, these are the ones where they give you the volume, the surface area, the area, all those different things. Here are some new geometric formulas we will use for this objective. So we have a circle. Remember, a circle is a 2-dimensional thing. It's not like a cylinder or a sphere. It's just 2-dimensional circle. Your circumference is the total number or the total length of the circle around the outside. The diameter is from one point to the other point through, of course it is, through the center. So here the diameter is going to be, it's a measure of how wide the circle is. And the radius is from a straight line from the point to the outside of the circle. So when you see the circumference equals pi times d, or 2 pi r, 2 times pi times the radius. And for those of you who don't remember, pi is an irrational number. It's a number that cannot be written as a fraction. It's what that means, the decimal goes on forever. But the approximation that we usually use is 3.14. Now, if your calculator has pi, you can use it. If not, just type in 3.14. So the diameter equals 2 times the radius, or on the other side that the radius equals 2 divided by the diameter. That's just going back and forth. The area is pi times r squared. The cylinder is when you have a circle on the top and a circle on the bottom, and then almost a rectangle that goes around the outside. So the volume of a cylinder, and remember, a volume means basically how much water could I put into this this shape? What is the inside volume, not surface area? The volume of a cylinder is pi r squared h, which is h is the height. The surface area is if you were to take all the parts and cut them out and lay them flat, what's the area? Again, with a cylinder, you basically have a circle on the top and a circle on the bottom. So that's this part, 2 pi r squared. That's 2 times the area of one of those circles because they're the same. And then plus 2 pi r h. That's also kind of getting at this thing on the outside. That's kind of a rectangle. If you were to flatten it out, it's a rectangle. Does that make sense? I wish I could cut out a shape and show you guys what it looks like. Actually, I can draw it for you really quick. That's what I could do. So if you have a cylinder, if you were to cut it out and just lie it flat, it would look like this. So it's looking at the area of this circle times 2, and then the area of the rectangle in the middle. All right. And then we have a rectangular solid, the volume, and we've done this a couple times. We have the length times the width times the height. And then the surface area. Remember, with a rectangular solid, you basically have 3 different sized rectangles, and each of them are twice. So you have the top and the bottom are the same, the front and the back are the same, and then the left side and the right side are the same. So you just do 2 times LW plus 2 times HL plus 2 times HW. All right, the brief overview, we've talked about this a few times. You have 2 different types of problems. You have a formula, which is a circular, like this is an example, a circular rug has a circumference of 28 feet. What is the diameter of the rug? You're given some formula. The circumference in this case is pi times d. Or one where you get to create an equation from words. Here's an example. You are putting edging on 12 circular rugs, each with a radius of 3 feet. How much edging should you buy? So you need to create an equation where you have amount of edging equals 12 times the circumference of the rug. Important notes, a circle is a 2-dimensional shape. You guys know what a circle is. A cylinder is a 3-dimensional object with 1 curved surface and 2 congruent circular or oval bases. Don't you guys like it when I say a rectangle and 2 squares or 2 circles on top and bottom? A rectangular solid is a 3-dimensional object with 6 rectangular faces. Pi is a mathematical constant that represents the ratio of the circumference of a circle to its diameter. Pi is about 3.14. That's the estimation we'll be using for this class and in most classes. Circumference is the distance around the edge of a circle. The radius is the distance from its center to any point on the edge. The diameter is the longest distance across a circle. Basically, you're just drawing, when you go from an edge to an edge, but it has to go through the center. Surface area is the total area of the surface of a 3-dimensional object, is measured in square units. Always ask yourself whether the answer makes sense, which I say all the time. All right, let's go down. We're on page 73. Let's go down to your turn 4. So we're looking at the circumference of a circle. So we have this circle. Is not a perfect, that's not even remotely close to perfect circle. So I can't even look at that. That's not much better, but at least the center is kind of in the center. Okay. At the entrance of Hastings Museum is a circular goldfish pond of 400 feet in diameter. Remember, the diameter is that widest length of a circle, or widest distance from edge to edge. Anytime you go from the edge to another edge through the center. So it's 400 feet in diameter. So the diameter equals 400. Find the distance around the pond, round to the nearest 100. So we're looking for this circumference. Okay, so now we know that the circumference equals pi times d, right? Pi is about 3.14, and we're given that the diameter is 400. So then C equals 3.14 times 400. All I'm doing is plugging in that number. We're given that pi equals 3.14, and then we're given that the diameter equals 400. So when we plug that in and we get the number, we do 3.14 times 400 equals 1,256. And there's no decimal point, so we don't need to round it all. Any questions about that one? Everybody kind of spacing out at this point? All right, let's look at a volume of a rectangular solid. We're on your turn 5. So I'm going to kind of draw this, even though my drawing is hideous. All right, so we're given, I'm kind of drawing this as we go on. All right, so we have the volume. We're given that the volume equals length times width times height. Okay, a storage container in the shape of a rectangular solid has 1,968 cubic feet of holding capacity. Holding capacity, what does that tell us? That's the volume. That means that this thing can hold 1,968 cubic feet. So we're given that V equals 1,968 cubic feet. If the container measures 20 feet long by 8 feet wide, how tall is it? So we're gonna say that the length equals 20.5 and the width equals 8. And we wanna know what that height equals. All right, so let's start plugging in some of our knowns. We're given this volume, so we have 1,968. So I'm plugging in my numbers for this equation. Equals, the length is 20.5, the width is 8, and we're looking for the height. So what do we need to do first? We need to multiply this number first, right? So we're given 1968 equals, we have 20.5 times 8 to 164. Oops, you guys can't see that. I'm sorry, guys. I can tell you're zoning out because you didn't even tell me you couldn't see it. So we're plugging in an unknowns, 164.0 times h. So we need to solve for that h. So we need to divide both sides by 164. So we have 1968 divided by 164 gives us 12 even. So the height is 12 feet. And pay close attention, it gave us feet. So we know that our unit of measure is feet. All right, any questions about that one? Okay. All right, let's see. Good, thank you, Joy. All right, let's do one more. So we're on page 76. And we have Carla needs to clean a circular rug in the foyer of a hotel. The rug has a diameter of 18 feet. 1 can of rug cleaner cleans an area of 120 feet. So what is the area of so we have part A, what is the area of the circular rug? So we're given a circle again, and we are given that the diameter is 18 feet. And that we are also given that 1 can equals 120 square feet, right, for now. So we need to find the area of the rug. So we're given, let me make sure you can see this time. We're looking for the area. So area equals pi r squared. But we're not given the radius, we're given the diameter. How do we find the radius? Does anybody remember? No. Remember that the radius is this distance, which is the same as this distance here, right? So if the radius is equal to this distance, we know then that 2 times the radius equals the diameter. But we need to know what that radius is. How do we solve for that radius? We were also given that the radius equals the diameter divided by 2. We were told that in the beginning, but we can also figure this out, right? So the radius equals the diameter divided by 2, and we're given that the diameter equals 18. That equals 18 over 2. So we're given that the radius then is equal to 9. Very good, Sarah. Good job. So now we need to plug that in. So we have pi times 9 squared. Does anybody know what 9 squared is? $81. Very good. So now we have 3.14 times 81. Which gives us about, and what do we need to round it to? We needed to round it to, let's see, the nearest 10th. So the answer I get is 254.34. So we need to round to here. That 4 tells us to round down. So the area equals 254.3. And if it asks for units, you would say feet squared or square feet. Okay, that's part A. So let's look and see what it says for part B. So we're given, let's say, so we know that the area for part B, I'm just going to write this down. Part is 254.3. And we were told that 1 can of cleaner covers 120 feet squared. Okay. So now they're asking, how many cans of rug cleaner should Carla order? So what do you guys think? How would we do this? We need to know how many cans. Can anybody think about how we would do that to figure out how many cans we need? So we need to cover that much room. Divide, very good, Joy. We need to divide the area by that to figure out how many cans we need. So we're going to say 254.3 divided by 120. So that tells us we have 254.3. And does it say round? How does it say to round? Round to the nearest whole number. 254.3 divided by 120. So 254.3 divided by 120. Oops, I just wrote that wrong. Sorry. 254.3 divided by 120. I get 2.11917. Now, here's the problem. If she orders 2 cans, is that going to be enough? No. So how many cans does she need to order? She would need to order 3 cans to cover that distance. Yes, exactly. Now, if it says to round, you can round down. You would round down to 2. But in this case, it's saying how many cans does she need to order to cover that rug? She needs to round, you need to round up to 3 for that case. Because if she only ordered 2, it'd only cover 240 square feet. It would not cover that. All right? All right. We're going to go ahead. It's 11:45. You know what I'm going to do real quick, just to round off this section, and we'll cover this one again on Thursday. I just want to show you really quick. It says an area of a rectangle. A billboard sign is 5.2 feet wide and 78 square feet of material is needed to cover it. What is the length of the billboard? So this one, I just want to set it up, and then we'll finish covering this on Thursday. So we're given a sign that's a rectangle, right? And we're told that it's 5.2 feet wide, and we don't know the length, but we're also given that the area equals 78. And we know that the area equals the length times the width. So let's plug in our knowns. We have 78 equals 5.2 times the length. So all we would need to do is divide by 5.2 on both sides. Oops. Those would cancel and the length would equal, I guess we're going on finish, this one's pretty easy, divided by 5.2. Gives us 15. Okay. Oh, can't see. I'm sorry, Joy. Sorry. So you're given that the area equals the length times the width. So we're given 78. Gosh darn it. There we go. We just plugged in the known. So area is 78. The length is the width is 5.2 times the length. So we just divide by 5.2 on both sides. That cancels, and then we're given the length. When we divide 78 by 5.2, we get 15 feet. All right. So that's it for section 5.7. That's it for new material. If you guys have any questions, you can let me know. Let me get you the practice problems for 5.7. So we have 11, 13, 17, 19, 21, 25, 27, and 31. So the good news about that, the final won't start until May 7th. So that's a week from Thursday. That means that we have Thursday of this week and Tuesday of next week for review and questions. So I will be sending out a final review document for you guys to follow along with me for the exam. I'll send that out either today or tomorrow, depending on when I get it all finished up. So you guys can have it on hand. So if you guys have any questions in the meantime, you guys can start working on your Module 13 quiz. That's the other good thing. That way, you guys, if you can finish that quiz before the next class, then you guys can focus on studying for the final exam over the weekend. So does anybody have any questions for me before we peel off? All right. If you do, email me and I'll get back to you as soon as possible. And I will talk to you guys on Thursday. Have a good week.